We are going to go ahead and look at this example 2, this from page 358 in your book. We have a base function of g of x equal to 3 to the x. I call that a base function. It's like a parent function. And we are going to transform that. It's going to be transformed into this negative 1/2 times 3 to the x plus 4 plus 1. Keep in mind when we transform a function, it's like what we've done in the past, it can reflect, it can compress, or it can expand, it can shift left, right, translate. So all of those things are still in play here. What I'd like you to do is pause the video and for yourself predict what you think happens to this function g of x equal to 3 to the x with all the stuff that you see there in that negative 1/2 business. So go ahead and pause the video, make predictions. You can go look at Desmos. We're going to do that here together in a minute anyway. So make those predictions and then come on back. All right, welcome back. Hopefully you had a chance to take a look at that. One prediction I'm going to make about it is that because it's a negative lead coefficient now, it's going to flip over. So it's going to reflect in the x-axis. The other thing is because it's a 1/2 there, I would say that that's probably going to compress. It's going to compress it towards the x-axis. And then we've got this 3 to the x plus 4. So I would say that's a translation, probably to the left. And then also a translation with the plus 1 there. So it's been translated up. So flip, compression, slide left and up is my prediction. So let's go over to Desmos and take a look and see, okay, indeed what's happened here. So we have our base function, 3 to the x, I'm calling that one f, like that's the beginning function. And then it's been transformed into g. So we've got that negative 1/2, 3 to the x plus 4 plus 1. So I would definitely say if we have that negative 1/2 there, it's going to flip it over. So it definitely has flipped. So not only has it flipped over, it has definitely been slid to the left and then up. Now, a way to check that to see did it actually slide left and up is you can just go to the original function here and put in, what is this? Oh, it's not going to let me do that. So I got to go plus 4. No, it's still not letting me do that. I'll just throw parentheses around it. So if you watch what happens to your original function here, when we put in what plus 4, we can see that indeed it's been moved left 4 places. Now you can track that by this number right here. So the original didn't have the plus 4 in here, but it was over here. It crossed over at 1 and it went left 4 there. All right, so we can definitely see that this has transformed. Let me get all this other business out of here. It has done this transformation of flipping, of moving left and up. But the question is has it compressed? So what I want you to do on that to check that is actually take your original function and throw just the 1/2 in front of it. So if we put a 1/2 in there, you can see that from the original without the 1/2, you can track this point right here. It was going through at 1. We know it would go through at 1 because the beginning value there is like having a 1 times that. So that beginning value going right along with our y-intercept concepts from before. But now if you put it in as a 1/2, watch it compress, it move down toward the x-axis. So if you go look in the text there, you can talk that through to yourself there. It says that a is equal to that negative 1/2, so it reflects in the x-axis, and it compresses toward the x-axis. And then it has a translation of, I would say it's going to be, it translates 4 units for the h value, it's 4 units left. And then the k value, it translates up 1 unit. All right, so you're going to want to also, look at this. There's an example in there. The book is also with an exponential decay being transformed. I'll let you do that on your own. I will see you guys in the next video. We will do a real world example, one that's actually created by I think I'm going to do one that's involving with, I believe, half-life. I'll go find one of those and we'll talk that through. Or we just might use the example 4, which is there on page 358 too. I don't know. You'll have to come see what's happening in that next video. All right, thanks, guys.